So, let us welcome back and continue the discussion on this turbofan engine. Rather, right now we are talking about these hybrid engines. So, the hybrid engine, that means either one side you could have the ram based cycle, the other side you could have turbine based cycle, and the turbine based cycle could be of turbojet based or turbofan based, and the ramjet could be a ram based cycle could be of ramjet, scramjet, or dual mode dual combustion scramjet. And then there are different configurations which are possible, and we have seen some example also. Now we are going to, and also we talked about the future technological challenges for this aviation industry in together. Now we are going to look at some of these engines details. Let us start with some TBCC engine and the propulsion system integration. So, the propulsion system integration, especially there, I mean, obviously we are talking about this hybrid engine where you have either ram based cycle or the turbine based cycle, and there could be important aspect of propulsion system configuration. So, which means either we could have wraparound configuration, and we will see some examples so that you will get an idea about what we are talking about here, or over under configuration. And the differences between these two primarily are where the, let us say, the position of ram with respect to turbine base or cycle or turbojet cycle, or so the position of AB of turbojet, let us put it very specifically, AB of turbojet with respect to the ram. So, that is what we said, the propulsion system integration is also important, and this the installation configuration of, let us say, wraparound configurations. I mean, we can see like this is one of the wraparound configuration, which is a for engine SR 71, and that is what it is. And the other one which is there, like one can have also, this is one of the example. Other could be that which could be fuselage Griffon 2. So, though I do not have the picture here, but you can see that that is also fuselage kind, but here you can see this is the turbine based cycle, this is ram based unit, and that is a combination. This is just an example, this is a wraparound cycle. Now, when you talk about over under configuration or over under turbo ramjet, then there could be possibility like this is an over under TBCC configuration, where this is a separate intake and nozzle. So, this could be one configuration, or here it could have shared intake and nozzle. So, it is already can give you an idea how they look like this. So, these are also comes under over under configuration, over under configuration. So, and this example here is like that, even in a over under configuration there could be, one can have fuselage installation, and this is exactly what it is here. this is a fuselage installation. There could possibly have wing installation, and there could possibly have tail installation. So, that means over and under configuration, that means where either the turbine based cycle or the ram based cycle, one of them would be top of the other, and that also can be done in different ways, like where we configure that depending on that it could be. Now, when it is a wing so this is a fuselage kind of installation. There could be wing based installation, where in the wing one could be in the top or the other, or some could be the tail based installations where there could be installation. But you can see these pictures in some book or internet. Now, another thing which would be important to the performance of this performance of TBCC. So, that is also important, because when we look at this performance of TBCC or hybrid engines, so there is a range where this could be operated, and there is like you can see, this is where the specific impulse is, and this is where turbojet works, where ramjet, where scramjet, and this is different fuel when you used, and then the different lines, dotted lines which were used for rocket TBCC. And if you look at this aspect where this shows the variation of the Mach number and with the cycle variations. This is the turbine based cycle and this is the ram based cycle, and that is where the hybridization gives an advantage and over this. Now, we can look at some of this analysis of this hybrid engine. This is an one wrap around turbo ramjet. So, let us look at that cycle analysis for that. So, operation as like we can so already we have done a lot of detailed discussion. Now, we can draw the schematic TS diagram for the same. Let us say if we put the TSS diagram, then this is point A, this goes to somewhere 8 and or in between somewhere 2, this is, then this goes to 3, then goes to 4, then this is 5 is 6, then this goes to let us say 0.6 AB, then so we can mark separate way, this is let us say 2. So, mark this 2, 8, so this is 0.9, then we can have 7 AB, this is 10. So, here this is a solid line, this will also go solid line, this will come solid line, and this also go as a solid line. Here the dot this is, so let us say this goes to dot and this is like dash dot, this could be dash dot, like that. So, dot 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 is turbojet AB off, solid is turbojet AB on, dot dot, this is ramjet operation. So, this is different situation, and already if you see, that means your A22 is intake, where the compression process with isentropic efficiency of eta d, then 223 is compressor, where the compression takes place with isentropic efficiency of eta c, then 324 is combustion chamber, where the heat addition at constant pressure takes place with little pressure drop, and combustor efficiency and delta P C C. Then 4 to 5 is your turbine, where again expansion takes place with isentropic efficiency of eta t. Then 5 to 6 is afterburner, where again the second round of heat addition takes place with delta P A B and eta A B. And then 6 to 7 is nozzle, where again expansion process with isentropic efficiency of eta n. And the other detailed cycle analysis of different conditions, these are already done in details. So, the performance like specific thrust, if we look at it like T m dot A is 1 plus F minus F A B V 7 minus V, and TSFC would be TSFC of turbojet, which is F plus F A B by T by m dot A. Similarly, propulsive efficiency eta P would be T by m dot A into V divided by T by m dot A V plus V 7 minus V square by 2 into 1 plus F plus A B, and thermal efficiency would be T by m dot A V V 7 minus square into 1 plus F plus F A B Q H V into F plus F A B, and overall efficiency is propulsion into thermal. So, these are the things which can be calculated. Now, we can look at if the operation as a ramjet engine only. So, if it is operation as a ramjet, the flow is passing through the processes, and so like what are the part would be. So, it will only have intake A to 8, then combustion chamber 8 to 9. So, intake, the compression process will take place with a pressure ratio R D, combustion chamber where the combustion will take place with delta P C C, and the nozzle which will be 9 to 10, where the expansion will take with n n. That means, when it operates as ramjet, so these are the stations which would be sort of active, and then we can calculate the parameter like performance parameters, like let us say T by m dot A for ramjet is 1 plus F R, which is for fuel ratio for ramjet V 10 minus B, and TSFC would be Fr by T by m dot A into ramjet, and our propulsive efficiency would be T by m dot A ramjet into V T by m dot A ramjet V plus V10 minus V square by 2 into 1 plus Fr, and thermal efficiency would be T by m dot A ramjet V plus V10 minus V square by 2 into 1 by Fr by QHV Fr, and overall efficiency equals to propulsion. So, this is when it operates as a ramjet. Now, when it operates as dual mode, so what would happen that time? So, when it operates as dual mode, then you get thrust would be of turbojet plus thrust would be combination of ramjet, then the total thrust would be m dot A turbojet into 1 plus F plus F A B V7 minus V plus m dot A ramjet 1 plus Fr V10 minus V, and m dot A turbojet 1 plus F plus AB V7 plus m dot A ramjet 1 plus Fr V10 minus m dot A total into V. So, similarly, the specific thrust would be T by m dot A. So, T total by m dot A total. So, we can calculate, and total fuel mass flow rate would be m dot A turbojet F plus F A B plus m dot A ramjet Fr, and specific thrust m dot total. So, this let us say total by T total. So, that is what it happens. Now, also one can look at the over under turbojet, and over under turbojet, this is some of the example. So, where the propulsion system integration is done, like this is a ramjet mode of that over under turbojet, and then this is another intake layout with different positions of the intake flap with subsonic and these things. Now, you can have one over under ramjet and can have look at this. So, this is quickly the TS diagram. So, this is A 02 8 3 04 comes to 6. So, 06 AB, this is 05 06, and this is again like so. So, this will come 7 AB. So, this is 10, this is 09, and this is 7. So, again same thing. So, solid line is turbojet AB1 dot turbojet AB off, this ramjet operation. So, and the general block diagram would be like you have turbine based cycle, then you have a ram based cycle, then you get all the performance calculations. So, from this combined cycle where it goes, let us say something comes here and then it goes V. So, from here it goes V turbojet, from here it goes V ramjet, and then finally you got T by m dot A TSFC. All this you can calculate. So, these are the calculations which you can do, where again like m dot turbojet would be m dot A turbojet by m dot A plus m dot F CC m dot F AB, and m dot ramjet would be m dot A ramjet by m dot A plus m dot F ramjet. So, there is a two different fuel mass flow rate calculations which you can take, and so this is how it looks like, and that's so then your thrust would be m dot A like turbojet V turbojet plus m dot A ramjet V ramjet minus m dot A V F and T by m dot A would be m dot A turbojet by m dot A plus m dot F CC by m dot A plus m dot F AB by m dot A into V turbojet plus m dot A ramjet by m dot A plus m dot F ramjet by m dot A V ramjet minus V forward velocity. So, similarly TSFC m dot FCC by m dot A plus m dot A by m dot A plus m dot ramjet by m dot A by T by m dot A. So, this is how the performance parameters can be calculated for this dual mode kind of operation, and then one can have the design procedure. The procedure could be summarized like some basic design procedure which could be put it to place, like one is the basically what you need for hypersonic or supersonic cruise aircraft propulsion integration. First is the mission or flight envelope to be selected. So, mission envelope to be selected. Second, so the squeeze altitude is important for fuel economy point of view, takeoff, climb, acceleration. Then we can calculate the drag force based on the drag forces with Mach number and all these. So, calculate the thrust force. If it is greater than the drag force all over is Mach number, then some margin of percentage to be selected. Then the number of engines which could be decided upon based on the minimum thrust which is suggested for the hybrid engines at different modes. Then performance calculations of each constituents of this engine separately. Let us say for example, hybrid engine has ramjet, turbojet and scramjet. So, each modules has to be examined separately, and then finally the integration. And 6 is optimization, that means this is very important of this hybrid engine for different step like specific thrust, TSFC, and then the switching point between when it is supposed to switch between ramjet and turbojet and which Mach number and all such things. So, just to conclude this all this discussion with this schematic vehicle of the future TBCC engine. So, this is a Lockheed Martin SR-72, which is sort of conceptualized unmanned hypersonic aircraft intended for intelligence, surveillance, reconnaissance, and this SR-72 was also could be operational by 2030, because it is again what you see here. It is a over under configuration. Here is the turbine engine, here is the dual mode engines, and it will be based on turbine TBCC cycle. Turbine engine will be used initially to take off up to Mach 3, and then this dual mode ramjet engine will accelerate to the vehicle to hypersonic speed, something like that. So, the turbine and the engine shares the common inlet that provides air supply to both the turbine engine and the ramjet engine, and also they have a common nozzle which is here. So, you can see this conceptualized or the sort of futuristic vehicle. So, it has also variable inlet and nozzle, nozzle rams open and close to match the cycle requirements. So, that is what you can see, and that sort of pretty much concludes the discussion on all these turbine based cycles and also the hybrid engines, and this give you a good idea about how these different kind of engines which are in place today and what is going to be futuristic vehicle and how would they operate, and what are the kind of this combined cycle performance parameters and sort of things. So, we will stop here and continue the other discussions in the next lectures.